Mars and Its Canals by Percival Lowell, Chapter 16, Their System. For outdoing in suggestiveness the individual traits of the lines is the relation shown by them to one another. It is the communal characteristics of the phenomenon that are most surprising. The individual peculiarities of the lines impress themselves at once, the communal only as the result of experience, collation, and thought. As the observer becomes trained, the more lines he is able to make out, until they fairly seem the whole surface of the light areas of the planet. Their name collectively is legion, while to name them individually is fast getting, for the number detected to be impossible. As with the increasing family of asteroids, figures alone will prove adequate to the task. Interdependence, not independence, marks the attitude of the canals. Each not only proceeds with absolute directness from one point to another, but at its terminals it meets canals which have come there with like forthrightness from the other far places upon the planet. Nor is it two only that thus come together at a common junction. 3, 4, 5, up to as many as 14 thus make rendezvous, and it is a poor junction that cannot show at least 6 or 7. The result is a network which triangulates the surface of the planet like a geodetic survey into polygons of all shapes and sizes, the Aryan areolas. The size of the pieces forming this tessellate ground depends solely upon the fineness of the definition. With every increase in the power of seeing, each areola is cut into still smaller portions, usually by connection between its corners. Thus, a polygon or rhombus is split into triangles which may themselves be divided in like manner, the mosaic breaking into bits, the sides of which, however, always remain clean cut. From this arrangement, it is at once evident that the canals are not fortuitously placed. That lines should thus meet exactly and in numbers at particular points, and only there, shows that their locating is not the outcome of chance. If very thin rods be thrown haphazard over a surface, the probability that more than two will cross at the same point is vanishingly small. Increasingly assured is it that this would not happen generally. The result we see is therefore not a matter of chance, but of some law working to that end. To the detection of what that law is precedes the easier ascertainment of what it is not. The lines, for example, cannot be rivers, which was the first explanation offered of them by Proctor many years ago, because of their peculiar straightness. Nor can they be channels, the name given to them by Schiaparelli, except in the non-committal sense in which he used the term. For here again their geometric regularity is bar to any estuary-like hypothesis. For quite another reason they cannot be cracks because of their uniform size throughout. Their unbroken character is another fatal objection to the same suggestion. For cracks in ground never pursue for any great distance a continuous course, any more than they keep uniform or straight. The state of an old ceiling is a case in point. When it breaks, it does so in fissures that proceed a certain way, then give out to be continued by others roughly parallel to the first, but parted from them. The same character is shown by the rills on the moon. The straight wall, so called, is composed of 3 such sections, and the little rill on the right of it, west of Brit, of 4. Thus they were seen at Flagstaff, and as, to the writer's knowledge, they have not been so depicted elsewhere, the fact may serve to give some idea of the definition there. That the underlying cause is not explosion or contraction is also evidenced by the canals collectively as well as individually. Their arrangement into a system for cracks, however produced, could only originate from certain centers and could not fit into those starting from others, as the canals invariably do. For each canal goes as undeviatingly to one terminal as it left forthrightly from another. If one wishes to see what explosion or contraction can do, he has only to look at the moon for an opera glass, when he will be shown a very different sight of what the drawings of Mars detail. Thus, just as, considered individually, the lines cannot be watercourses because of their straightness, so they cannot be cracks because of dovetailing into one another. The fact that they form a system shows that whatever caused them operated over the whole planet, linked in cause as an effect throughout each section. This at once negatives any purely physical cause of which we have cognizance. For upon a globe still so subject to physical vicissitude as Mars by its aspect shows itself to be, latitude must tell in the phenomena its zones exhibit. Polar snows that wax and wane speak of Arctic conditions very diverse from temperate and tropic states, and what would affect one could not influence the other. Yet the mesh rises superior to zonal solicitation as to local barrier. It is not something dependent either on the temperament or the complexion of the globe's different parts. It transcends surface restriction and becomes planet-wide in its working. The importance of this omnipresence dilates in meaning as one dwells in thought upon it. Ubiquitous as it is, the mesh which thus covers the Martian surface like a veil spread completely over it is unlike a veil in being irregular in texture. Not only are the interstices of various shape and pattern, but the mesh itself is of locally differing size. Though the threads are straight and uniform throughout, they are not all alike, besides being unsymmetrically interwoven. Some are at least of 10 times the coarseness of others, and from this fact and the Bo-Peep effect of our airwaves, all are not visible at once. In consequence, the network is not so impressive at first glance as it becomes upon a synthesis of the observations. When this is done, the surface proves to be fairly evenly cut up, as recourse to the maps printed in this volume will amply demonstrate. These maps, as on page 31, are made from the result of but one opposition, and at each opposition some zone is in a more canal-showing state than others, owing to the Martian season at the time. A still greater uniformity in canal distribution results from a blending of many. From the completeness of the mesh, it follows that in the course taken severally by the canals, no one direction preponderates over another. Considered by and large, the canals seem to be equally distributed around the compass points, and this at all longitudes and nearly all latitudes. Tropic, temperate, and even Arctic canals show a pleasing impartiality in the manner of the course pursued. The only exceptions occur in the neighborhood of the pole. There, a slight tendency may be seen to a north and south setting. Though so much is visible in a general way from the map, it is of interest to go into the subject with more particularity, and to that end to show it statistically. The several canals traversing each zone were therefore counted, and the area of the zone computed. The manner of canal distribution thus found is given in the following table, in the second column of which stand the areas of the several zones upon the planet, each 10 degrees wide, except the one next to the snow, and in the third, the number of canals found traversing them, reduced to percentages of the 0 to 10 degree zone. A fourth column shows the total length of the canals in each zone, those from 0 to 20 degrees being taken from the 1896 globe, those from 20 to 90 degrees from the 1903. This is in order to annul the effect of the season upon the showing of the canals as much as possible. Zone 0 to 10 degrees. Area 1. Number of canals weighted 1. Actual length 1. Zone 10 to 20 degrees. Area 0.97. Number of canals weighted 0.89. Actual length 0.91. Zone 20 to 30 degrees. Area 0.91. Number of canals weighted 0.93. Actual length 0.72. Zone 30 to 40 degrees. Area 0.82. Number of canals weighted 0.90. Actual length 0.71. Zone 40 to 50 degrees. Area 0.71. Number of canals weighted 0.78. Actual length 0.66. Zone 50 to 60 degrees. Area 0.58. Number of canals weighted 0.64. Actual length 0.59. Zone 60 to 70 degrees. Area 0.42. Number of canals weighted 0.43. Actual length 0.42. Zone 70 to 80 degrees. Area 0.26. Number of canals weighted 0.30. Actual length 0.34. Zone 80 to 85 degrees. Area 0.07. Number of canals weighted 0.12. Actual length 0.11. The numbers continue fairly non-committal until we begin to approach the pole, when they commence to increase. Much the same result is got if we take the actual canal lengths in each zone, as the fourth column shows. The crowding of the canals poleward is marked. The canals, therefore, are phenomena that stand in peculiar relationship to the polar cap. This corroborates the inference about them due to their running out of the edge of snow. They not only emanate from it, but they do so in numbers surpassing what is elsewhere observable over the disk. Otherwise, it is with their departure points. These are not scattered haphazard over the surface, but bear to its general features definite relations. If we consider the map, obliterating the lines, and then seek to connect the most salient points of the planet's topography by direct avenues of communication, we shall find that our putative lines fall exactly where the real ones occur. For the most part, the real lines emanate from well-marked indentations on the dark regions, fitted by natural position for departure points. What, if these were seas, we should call their most conspicuous bays. They thus leave in the southern hemisphere the deepest folds of the great diaphragm, for the most part, though on occasion they run out of them where they will. From equally conspicuous points in the dark northern areas, other lines proceed, while in the center of the continents the canals make for more or less salient spots, small patches of shading like the Trivium or the wedge of the Cassius, or simply round black gradients like the Lucy Ismeni. From this it appears that the lines are locally dependent upon the general topography of the fundamental features of the surface. For some reason they connect the very points most suggestive of intercommunication. As from their characteristics it is perfectly evident that the lines are neither rivers nor cracks, it follows that such a communicating habit is of the most telltale character. To be so dissimilar in kind from the main markings, and yet so dependent upon them, hints that their positioning occurred after the formation of the main features themselves. We reach thus from the look of the lines and their location a most striking deduction, that the lines are not coeval with the main markings, but have come into being later and with reference to the general topography of the planet. The network is not only a mesh de facto then, but one de jure, which, subsequent to the fashioning of the seas and continents and what these have now become, has been superposed upon them.
End of Section 17. Recording by Michael Knowles, Fort Worth, Texas.